Okay, hi folks. My apologies again for not being able to make it into the tutorial this morning. But hopefully this video will be useful because I believe that a number of you also didn't make it in. So this then will serve as a sort of overview of the module for everyone's sake. So for those who don't know me, my name is Andrew Brown. My colleague Mirta was in this tutorial this morning. So you might have met her already. You may have encountered us in previous modules. If so, I apologize for that. But hopefully we'll have a good time on this module. I'm actually really excited about teaching this. This was one of my favorite modules when I was a student. And also it's been several years since I've actually had a class where I've got to spend time in a classroom with students. So I'm actually really looking forward to getting to spend some time getting to know each of you and working with you on this module. So I look forward to meeting you hopefully in the tutorial on Wednesday. So in this short talk, I just want to give an overview of the module. All of this information is available on Canvas, so you may have already read it. I just wanted to give this video so that you can put a face to the name and also maybe fill in some of the detail. So first of all, just the logistical details for the module. We will have face-to-face classes for this, hopefully no more of them interrupted by snow. And our class times will be 9 a.m. on Tuesday and then 1 p.m. Wednesday, Thursday, Friday. The first three of those are all in room 6 on the ground floor of the map. And then our Friday classes in the big lecture in room 17. This Thursday, there will be no class because the campus is closed, and I'll explain more about what we'll be doing in the next 2 weeks of classes anyway, so you can sort of know what to be getting on with anyway. I put here attendance question mark, and the reason for that is because the Canvas pages that we inherited from the previous lecturers, they had written on them, and this is still there, and you will have read it. It's that sort of attendance is required, that you have to come along to the classes. I think a slightly different view of this, and I think Mirta is on the same page, in that these classes are for your sake. Okay, we're not doing them to sort of check some boxes, and you know, it's not like our pride's going to be hurt if nobody shows up. Really, you have to make a decision about what is useful for you. As I'll explain in a few slides' time, this is not like a traditional lecture course where we are delivering information in every class. Really, these classes are tutorials during which you will be working on your projects. So insofar as it is useful for you to be in the room so that you can speak to us, and in the first few projects at least speak to your teammates, then please do come to the classes. If it's more useful for you to spend time working by yourself in the library or at home, or if you have arranged team meetings at different times that suit you better, that is absolutely fine. We will put up the sort of attendance QR code for you to log in, as in to sort of register your attendance at each class. That is because the university requires us to track attendance at these things. But to be honest, like I said, I imagine that as the module wears on, several of you will decide that actually your time could be more usefully spent doing other things and not coming to class, and that is absolutely fine. We will check in with you and just make sure that things are going okay, and obviously there are regular submissions throughout this course, so it should become fairly obvious fairly early on if people aren't keeping up with the work and that kind of thing. Okay, so please do come to the classes. I'm looking forward to getting to know you. Please also know that we're not going to be breathing down your necks making sure that you do show up if you decide that that's not right for you. Okay. Let's talk a little bit about what this module is all about then. So the learning outcomes for this module, you can read the sort of full written out versions of these on Canvas. But basically, there are 2 learning outcomes. The first of these is that you will, by the end of this module, you will have experience of and you will be able to address unfamiliar problems by developing mathematical models. So there's 3 parts to using mathematical models. There's actually developing the model itself. Then there's solving that model to provide us a solution to the problem. And then there's proposing extensions or refining the model. These are the kind of 3 stages of any kind of mathematical or scientific project which involves mathematical modeling. So most of the teaching that you have received up to this point in your degree, most of the projects that you've done will have focused on the second of these, on solving the problem. Okay. In this module, we're trying to give you a little bit more latitude, a little bit less guidance at the start of the process so that you get some experience in developing the model for yourself. So you have to think about the problem, think about what would be the useful mathematical tools for solving that problem, what's the best way to kind of cast the problem in mathematical language, What are the variables? What are the things that are fixed? What are the things you actually need to find? All of that kind of stuff. The developing part is kind of a free part at the start where you have a lot of choice about how you're going to set up the problem. Okay, not all of those choices will lead to good solutions, but you have a lot of choice in that. And there are some basic skills that we can give you in that in terms of just how to think, how to organize your thinking and so on. And that will be largely what we're doing at the start of this module is helping you to think about how to set up the models we're going to solve. Then you have the solving part. So this may involve you, deriving some equations. It may involve you writing a short piece of computer code to solve the problem. But in any case, you reach some solution. And then, of course, you have to analyze that solution and decide whether or not it's an optimal solution or maybe there's a better way of doing things. And that all then goes in as part of this extension is that can you then change the problem or extend it to a more general case? Can you propose a different problem, which is maybe has some interesting features, which is an extension of the original problem that you've addressed? Or can you perhaps propose some refinements to the way that you solve the problem that would allow you to solve it more easily? All of these come under this this sort of extend part at the end. So we're trying to give you the whole range, basically the whole kind of life cycle of the research project. As you see the problem, and then you have to go right from developing the model, solving the model, and then right back around again in this kind of refinement loop. Okay, so that's the first learning outcome, is basically you would gain experience in it by the end of the module. You would have done that several times and now will be able to do that again, especially as you're moving into your master's year. Second learning outcome really is attached to the second, or the last piece of assessment that we'll give you, as I'll explain. And this is that you will be able to research an unfamiliar topic, basically by reading about that topic, but also by talking to people who know about that topic. And I'll explain how we're going to manage that in a second, but really I just wanted to point out that the learning outcomes here really are aligned with getting you ready for your MSci year. So hopefully all of you will go into the fourth year, at which point you will have a full year-long project to take on. And some of those projects will be basically the supervisor gives you some sort of model and you just have to solve it. But some of them you will have to develop and model yourself. All of them you will have to offer some level of analysis, extension, refinement, all that kind of thing. But the big thing which is missing and which has been missing from this course in the past, and this is the big change that we brought in, is this ability to research an unfamiliar topic at the research level. Okay, a lot of the research, quote unquote, that has been done in previous years has basically been read a textbook, write the textbook, okay, sort of paraphrase it, and it's not a particularly useful exercise, because when we are researching a new topic, we don't just read the textbook and then write it out again. What we're looking for is trying to understand the context, trying to understand the interesting questions, and trying to then understand what various people have done in that field to address the interesting problems, okay, and that's more what we're kind of targeting with this second learning outcome. So the hope is that basically by completing this module, you will be then ready to take on a master's project in your next year. Okay. What will we then actually be doing aligned with this? Well, for the mathematical modeling part, we're going to have 3 short projects. Okay, there's the team practice project, which you might have already started work on already in the first class. Then we'll have a pairs project, which you work on with another person in the class, and then finally a solo project. And basically we have a big booklet with 47, I think it is, different projects in it, and you can kind of choose which ones you're going to do for these pairs project and solo project. Okay, and we'll try to accommodate your preferences in that in terms of what style of mathematics is used, whether it's a stats project or an applied maths project or a physics project or whatever, whether it involves computer programming, kind of analytical work, whatever it is. There's lots of different things in there, and you can have a look and see. And then we will support you in developing the mathematics, developing the model and solving the model and proposing the refinements. Okay, so that's what we'll actually be doing. Our classes are not going to be us teaching you lots of stuff about mathematical modeling or anything else like that. There are other modules which do that. Instead, we're just going to be supporting you in this process of exploring within these mathematical models. Okay, so that's actually what we'll be doing within our classes, is you'll just be working on these projects either in teams or pairs or by yourselves. And then the last part is the long investigation. So at that point, actually in the timetable, the classes stop, although we probably will organize some sessions to help support you with that. And really then you'll be working directly with an academic supervisor. So this is somebody who has done a piece of research, and then you're reading their work and talking to them about it. And that then is the long investigation, which is actually our last assessment piece, okay? So on that theme, like how are these all assessed? So the team practice project, you'll be assessed via a presentation. So the 3 or 4 of you in your team will stand up and give a presentation for 10 minutes on the problem that you've tackled, how you've solved it, and how you've extended and refined that approach. That will be 10 minutes long. That will be given next Friday in our usual slot from 1 to 2, and that's worth 20% of your final mark. So there you go. By the end of 2 weeks, you'll already have 20% in the bag, right? Then your pairs project, that will be assessed via a short report that you write, okay? And when we say short report, we mean short, okay? It's only 3 pages in length. Now, that is quite short for the amount of work that we expect you to do, but what we're expecting is that you will perhaps supply some supplementary materials to go along with that, with those 3 pages. So the 3 pages really is a short, focused summary and explanation of the problem and how you've solved it. And then the supplementary material will maybe be additional figures or pieces of computer code that you've written or long derivations that you've gone through, whatever it is, to kind of demonstrate the quantity of work that you've done. But really our focus here is on the quality of the communication of how you've actually solved the problem. Okay, so the first one of these, the pairs project, is a short 3-page report which you will write together. It's worth 15%. There's actually an additional little piece out here where you have to sort of write a reflection on how you did the project and how you worked well together as a team. That's part of the assessment for that. But really it's focused on these 3 pages that you submit. And then the solo project, again, it's a short report which you write yourself this time, and it's 3 pages, again, with supplementary material, and that's now worth 20% of your total mark. And then this long investigation comprises the largest part of the marks, so 45% in total. But what you'll see is that the report that we're looking for here is not long at all. Okay, in fact, it's 1 page. Now, this is actually quite a difficult exercise. I will be showing you a sort of example that I attempted. So I read one of my colleagues' papers and I wrote a sort of 1-page summary. And I did very poorly in this exercise, okay? Now, admittedly, I only kind of did the first draft. I could have refined it and done better. But this is a very difficult thing to do because you really have to understand the whole context in order to be able to write a good, clear explanation of what has been done in a piece of work. So writing a short report, what we're aiming for here is to have a really high quality piece of work where you are able to write and rewrite and draft and improve and refine what you've written. Okay, so we're not looking for a 40-page report. We really are focused on 1 page of really high quality work. And then to accompany that, we want this research diary, which is basically an explanation of the process you went through in order to complete this research. Okay. Now we will be explaining more about each of these assessments as we go along, particularly for the long investigation, because this will be perhaps a slightly unusual type of project that you've maybe never done before. So we will be giving you examples and showing you a little bit more about what we expect here. But this is the breakdown in terms of what you're going to need to do. And you'll see that this adds up to 100%. There's no kind of big final assessment. There's no exam or anything like that. So completing these projects basically means that the module is done and you'll all pass with flying colours, of course, and not have to worry about an exam at the end of this. Okay, when we'll be working on these, there's no overlap here. So basically we just do one after the other. In the first 2 weeks, you're going to be working on this practice presentation with your team. Weeks 3 to 4, so then you have 2 weeks to work on your pairs presentation, your pairs project. Weeks 5 to 7, that's 3 weeks then to work on your solo investigation. And then the last 5 weeks of the semester are focused on this long investigation. And we call it a long investigation because you're spending a long time on it, but as I want to reiterate that the piece of work that we're actually looking for at the end is very short and to the point. Okay, so really this is the overview of the module in terms of what you're going to be doing week to week, what your assessments will be, what the goals are for the module. As we go through class to class, we will obviously kind of talk to you a little bit more about what's involved in each individual project and so on. For the time being, your focus is going to be on this Teams project. The team lists are already available on Canvas. If you just navigate to the modules view and go to the section, the module on Canvas called Weeks 1 to 2, you'll see the description of the project, which team you're going to be in, and then the actual problem which you've been posed. So those of you who have been in class already will have already started working on this. If you weren't in class today, if you weren't able to make it in, then you can have a look there and see who your teammates are and what the description of the project is. And you can already start working on that, sketching out some ideas for yourself. And then when you get together in class tomorrow, perhaps, that's when you can start to share your ideas. Okay, we will be giving you some information at the start of next week about sort of tips and for how to prepare your presentation. But really all of the classes this week will be focused on working on the actual problem and developing that solution together. Okay, so just to summarize then, we will be meeting in these tutorials on Tuesdays, Wednesdays, Thursdays and Fridays. All we're doing is working on these projects. Occasionally we will be delivering some material in terms of tips for writing the reports, for instance, or some further guidance on how to tackle unfamiliar problems. But in general, these classes are for you to do work on the projects. Obviously, we're expecting you to work on them outside of those of the class time as well, because working on the projects is obviously the entirety of the assessment. So we're expecting you to put in the time either working as part of a team or individually in order to do that. So we expect that you'll be making progress on the projects in between times. If you need to contact us, you can do that in all the usual ways, but obviously the tutorials are also a good time to grab us and have a chat. So I'm looking forward to meeting all of you. I hope this was clear. If you have any questions, you can ask me about it tomorrow or just send me an email. But good luck, and I'll see you all soon.